Okay, hello chemistry students. Welcome to our final video for the week. So we are going to be observing different demonstrations of reactions occurring that demonstrate our different factors that are affecting rate law. So I'm just going to share my screen so you can see what I see. Okay, so as always, here's my contact information. So if you have any questions, concerns, emails, please contact me. Comment on the video, comment on Google Classroom. I see that you guys are communicating a lot with me, so I really appreciate that. So let's make sure we're keeping that up. And then those of you that aren't are texting me, emailing me, so I make sure that you guys are on the right track and just see how you guys are. So our standard is the same, so it's going to be HSPS15, and we're looking at factors that affect reaction rates. So our objective for today is I can observe varying rate changing reactions to determine what factors affect the reaction rate. So first things first, let me show you where we are on the packet. So where we are in the packet is at the middle of page 9. So we're going to quickly just write a couple notes about what are the three parts of collision theory, which is the theory of how gases behave. So in order to create a reaction, what needs to happen? And then we're going to get into you guys watching the videos of the demonstration. So copy these down as we're writing them. So pause the video, pause me as needed. So the three parts of collision theory. So one is molecules must collide in order to react. And that should make sense because if stuff isn't coming into contact with each other, how could it ever create an explosion, create just a change in anything? So, and the next two are pretty wordy, but basically what they're just saying is there must be, number two is there must be enough energy in order for these molecules to react. And we've talked about that last time. We talked about what activation energy was. So there must be this minimal amount of energy in order to, for a reaction to occur. Because if there's not enough energy, it won't be able to get over that bump for the activation energy. And then number three is as temperature rises, molecules move faster and are colliding more vigorously, meaning they're colliding more at like a higher rate more often. So it's greatly increasing the likelihood of bond breakage upon this collision. So that also should make sense. So as stuff starts to move faster, it's creating a bigger or a faster chemical reaction. So pause the video, rewind it as needed to get all this written down. Welcome back. So now we are going to move on to the reactions, which is basically just what we're working on for the rest of the packet for this week. So you guys, if you've already downloaded the packet, I apologize. I put this in last night. So you can hover over each of the reaction set of the new document, click on it, find these YouTube videos. It goes to YouTube and there's a demonstration that's happening. Okay, so we're not going to watch all these together. This is for you to watch and then decide what's happening with the video. So listen to this man. They're all the same man. So we'll have consistency there. And so listen to what's happening, observe what's happening with your eyes for these reactions, and then write them here. So the first one is dealing with the effect of concentration on a reaction rate. You're going to fill in the blank and then fill in these observations. So experiment 1 versus experiment 2. So when there's only this much hydrochloric acid, and then when we go up to 6 molarity of hydrochloric acid, so we're making a bigger jump with the concentration. So what are the observations? And then you're writing your conclusions here. And then finally, you are doing models for the concentration. So high concentration versus low concentration. So high concentration, meaning that there's more of this stuff, right? Low concentration, meaning there's less of. So draw a model of what's happening with these molecules. Like they're colliding with each other, as we know, to form a reaction. But if there's more versus less, what does that look like? So pause the video now to watch the reaction set 1. You can click on it here, or I'm going to post them all in Google Classroom. So pause the video now to complete reaction set 1. Welcome back. So by now you should have completed up until the models of high concentration versus low concentration. So you should have completed all up until halfway through page 10. So now we're going to move on to reaction set 2. So same thing, you click on this, it can take you to a YouTube video.
Now we're going to look at tough.
It's the same gentleman as I already stated, and you are doing the same thing. So instead of this time, we're looking at the effect of temperature on reaction rate. So we're going to look at glow sticks in an ice bath, glow sticks in room temperature water, glow stick in hot water. So record your observations there as the gentleman puts these videos. You can do a split screen, maybe that would be most beneficial for you guys. And then you're creating your conclusions. And for right now, don't worry about these graphing models. That might be confusing for us, so don't worry about that. So pause the video now to complete reaction set 2. Okay, welcome back. So by now you should have completed halfway through page 11. So reaction set 2. Again, we skipped this graphing models for now. We'll work on that more next week. So now you can work on reaction set 3. So same thing. This is a link, and I'll also post it in the Google Classroom so you have it. So first things first, make sure you're defining what surface area is. And then experiment 1 versus experiment 2, you're like always are recording your observations. So you're basically just following what these guides are saying and then creating your conclusion. So increasing the surface area of a solid chemical, blank, so increases or decreases or does nothing to the rate of the reaction. And then as you're doing this, draw a model at the very end. So as we're creating a smaller surface area to a greater surface area, what is happening? So what is happening at the molecular level? So what's going on with the amount of particles or the amount of collisions that are happening? So remember, we're thinking of chemical reactions as these collisions happening between different molecules. So what happens as we go from a small surface area to a larger surface area? What's the likelihood of these reactions? So just model that, draw however you'd like. I'd like to see how you guys are interpreting this. So not going to give you too much guidance in that. So pause the video now to complete reaction set 3. Okay, welcome back. So by now you should have completed up until halfway, a little bit, a quarter of the way into page 12. So we're almost done with your packet. Good job, you guys. So finally, we're going to go to reaction step 4. You're going to click on the YouTube video that has to do with the effect of a catalyst on the reaction rate. So again, like always, you're just observing what's going on in these videos. So the experiment with no catalyst versus with the catalyst, what are your observations? And then conclusions. So what can you interpret adding a catalyst does to the rate of a reaction? And then completing that, make sure you're defining what a catalyst is. We defined that last time. So use your resources, the packet that you're completing. So pause the video now to watch the video on the effect of a catalyst on the rate of a reaction. So welcome back. So by now you should have completed up until almost page 12 on your packet. So you should have just completed the reaction set 4. You should have defined, last thing you should have done is define what a catalyst is. So now we're working on the synthesis questions. So these are your the questions that I see how you're thinking about this. So you're going to pause the video, take the next 10, whatever, 15 minutes. If you can do it in 5, that's great. So take the next however many minutes you need, pause me to answer these 1, 2, 3 questions on the bottom of page 12 and into page 13. And this is the end of your packet. So you are completing these 3 questions right here. So pause the video now to do that. Okay, welcome back. So you should be complete with 1, 2, 3 questions on page 12 and 13. So this is the end of your packet. Good job, you guys. This is the first packet that you've completed fully. That's really impressive. You should be proud of yourselves. Make sure you are emailing these with me, sharing these with me, just so I see where we're at and that I see that you guys are doing it. So some of you I haven't really heard from, but if I see that you're emailing me the packet, then I know that you're doing it. So make sure you do that. And that's the end of the week. So looking into next week, we have a new upload on Monday at 10 a.m. as always. We're gonna start Google Hangouts instead of the YouTube Lives on Tuesday and Thursday at 10:30 like always for C Block, because this is a way that we'll kind of do a big video chat, so I'll be able to see you guys. It'll be more live rather than the little lag that's going on with YouTube. All the bugs with YouTube are difficult in this way. Yeah, we'll just be able to see each other, and I'll post the links for that on Google Classroom. And then we'll have more uploads on Wednesday, another Google Hangout on Thursday, and then another upload on Friday. So we're going to be continuing our talk of this reaction rates and how they're affected. As always, make sure you're keeping in touch with me. Email me your packets. Again, make sure you're commenting on the videos, on Google Classroom, emailing me, texting me as questions come up, as concerns come up. Have a great weekend, you guys. See you next time.